Good day, students, and welcome back to this class. So, we're going to tackle this question. Figure 4.77 shows the intersection of a main highway with a secondary access road. Vehicle detection sensors are placed along lanes C, D, A, and B. These sensors output low, 0, when a vehicle is present, and high when a vehicle is present. High is 1. The intersection traffic lights to be controlled according to the logic. So, what we're actually interested in this question is just the logic. So we know from the first part of the question, we know we have four input sensors. And when we have four inputs, this is what the table is going to look like. These are our four inputs A, B, C, D. Now we are interested in the output. The output is for first the east W light and the second is the north south light. So the east W light, the conditions for the east W light to be on or green rather will be whenever both lane C and D are occupied. That's this first one. And EW light will also be given whenever either C or D is occupied, but lanes A and B are not both occupied. And last for EW light is it will be green when no vehicles are present. So those are three conditions for the EW light to output one. So we're going to focus on one, two, and three. We'll come back to the north south light. So my output for east W light, I'm going to place it here. So let's work on the first condition. It will be green when both C and D are occupied. That means C has to be 1 and D also has to be 1. So let's look for conditions like that. So no need to okay, I can see here C is 1, D is 1. I'm going to output 1 here. I can see here C is 1, D is 1. I'm going to output 1 here. C is 1, D is 1 here. C is 1, D is 1. So, sorry, no 1, 1. So we have gotten our first trial. Now, the second condition is the AWI to be given when either C or D is occupied. When you see or, is either this or D is occupied. So either C is 1 and D is 0, or C is 0 and D is 1. So and also this is the first condition, but lanes A and B are not both occupied. So we cannot have A and B having 1 and 1. This is not possible. They are both occupied here. So we can only have when only one of them is occupied and when none of them are occupied. But we cannot have when both of them are occupied. So these are the two conditions we're going to be working with. So let's start from the first row. You can see A and B are 0, 0. Okay, that can go. And C and D are 0, 0. For now, this is not the condition we want to work with, but we'll get back to that. So let's go to the second row. A and B 0, 0. Okay, this checks out. Let's see if C and D checks out. D is occupied. So remember we said either C or D should be occupied. So this is going to have 1. Now the next row is there A and B are not both occupied. This checks out. C is occupied while D is not occupied. This verifies our condition. Now A and B, okay, A and B are not both occupied. So this checks out. But C and D, none of them occupied. So this does not check out. A and B are not both occupied. And C or D, one of them is occupied. So this checks out. A and B, not both occupied. Only one of C and D are occupied. This checks out. You can see between A and B, only one is occupied. And between C and D, nothing is occupied. Our condition says either C or D, and none of them occupied. So this will give us 0. Next line, A, between A and B, only one is occupied. So this checks out. And between C and D, only one is occupied. So this is 1. Next, between A and B are not both occupied. This checks out for me. And C and D, only C. We have C or D. C is occupied. So this checks out. Next line, A and B are both occupied. So this condition cannot even go. A and B are both occupied, cannot go. A and B are occupied, cannot go. A and B cannot occupied, cannot go. So I'm going to have 0, 0, 0. Yes. Yes, I'm going to have 0, 0, 0. And okay, and let's look at the last condition here for is W light. It will be green when no vehicles at all are present. So A, B, C, D all are 0, 0, 0, 0. Okay, see that happens in the first row. So here you can have one. And we have filled all our blanks. I'm just going to erase this full space. Okay, so now we have filled all our blanks. Now it's time to assign the product of sums. Yes. So this will be A, B, C, D. Now we know A is 0, B is 0, C is 0, D is 0. That means they all have negations. So not A. That means it's 0. Now A, B, C, D for this next one. A is 0, B is 0, C is 0. So all going three of them are going to have bar. D is not going to have bar because it's 1. Next line A, B, bar bar, C, D bar because D is 0. Next line A bar B bar C D. Next line. Okay, we're going to skip this 0 because there's no need of it since it's 0. We're going to have A bar B C bar D. Next line A bar B C D bar. You can see. Next line we're going to have A bar B C D. Next line we're going to have A bar. No, we're going to have A because A is one there here. A B C bar bar D. Next line A B bar C D bar. Next line A B bar C D. And the last one A B C D. None of them are 0, so we can do this. Okay, so now next I'm going to write out my Karnaugh mapping. So I'm going to have A B bar bar, A bar B, A B, and A B bar. So this is what I'm going to have for my column, or yes. Then for the row, I'm going to have my CD bar bar, CD bar, CD, and then CD bar. Now I'm going to fill in the gaps. Now here we have A bar, B bar, C bar, D bar. So here we have A bar, B bar, and here we have C bar, D bar. So I'm going to put one here. Next we have A bar, B bar, that is here again, but we have C bar, D, which is here. So one. Next we have A bar, B bar, here again, C, D bar, it's here. So I'm going to put one. A bar, B bar, here again, C, D, which is here. I'm going to have one here. Now the next line, we're going to have A bar B and C bar D, which is here. So you're going to have one here. Next line, A bar B, this C D bar, this that is here. So you're going to have one here. Next, we're going to have. We just finished with this. So next, we're going to have A bar B, still on this line, C D, that's here. We're going to have one. So going to have one here. Next, we're going to have A bar B here, C D. Okay, we just did this. A B bar, that is here. Let me erase all these other arrows. A B bar, that is this line here. C bar D. One. I'm done with this. A B bar here again. C D bar, that's here. I'm done with this. A bar B here again. C D. Put our one here. Now we have the last one, A B C D. That's A B. And where is C D? C D is here. So we're going to have one here. Now we're done with bringing out our values on the Karnaugh map. We're just going to copy this and paste for good measure. Okay, so we have this. Now I'm going to start selecting my ones. You can only select in groups of 2 and 4, but do your possible best to select in groups of 4 for good reasons. Now first I'm going to select this 4 I'm saying here. So this is going downwards and that is looking here. So I'm going to go through this and see what is going to cancel out. Now let me show you how to look at that. So if I go from here to here, A bar still remains A bar, right? But B bar became B. It if it was negation, then it became just B. It will cancel out itself. Now if I go from here to here, you can see it was A bar before. Now it has come A. It will cancel out itself. So A and B have cancelled out in this column. So all we're going to be left with is just what is at that row, CD. Now plus, next we're going to move on to the next line. I'm going to select this group of four I'm seeing here. So let's first go like this in this direction. So I'm going to have, if I go from here to here, I can see C bar still remains C bar. But when I go with the D, I see it was D bar, then became D. To cancel out. So D has cancelled out. Now let's continue with the C. C is C bar here and becomes C. It's going to cancel out. So nothing is left on this column part, but something is left here. So this is what we're going to use, plus A bar, B bar. Now next, we're going to select our next group of four. So my next group of four is going to be this. Just for good measure, this is what I selected. You can see it clearly here. Now if I go across the row, C bar became C. It cancelled out. But D still remained D. So D is left here. And if I go column wise, A is still A bar here, but B bar became B. B cancels out. So all we're going to left with is A bar. Now, next, I'm going to select my next set of four. Let's select this. Just to show you clearly what I have selected. This is it. So we're going to start moving row wise first. So if I go from here to here, C still remains the same, but D became D bar. It cancels out. So all we're going to left is with C, and then we're going to go column wise. A to A bar still remains, but B bar cancels out to become becomes 0. So all we're going to be left with is A bar. Now the next selection I'm going to make is, I want you to watch closely. I'm going to do this. I'll just show you what I did here. Clearly, I did this. This is still a group of four. In Karnaugh mapping, as long as the values are at the edge, that is at the base of the grid, you can see these ones are the beginning and end of the grid. I can do this selection. It is allowed. You can also do a selection of just two, but I want to work with four because it reduces the amount of algebraic equations I have to work with at the end. So first I'm going to go row wise. We go from here to here, C bar to C. C cancels out, D remains the same, so plus D. And I'm going to go row column wise. So this column is a bit tricky. It starts from here, the first value is here, and the fourth value is here. So I'm going to go from here to here. A bar becomes A, but B bar still remains the same. So I'm going to have B bar left. At the next selection, I'm going to make is this and this, because they are still on the edge. Just to show you clearly what I did, is what I selected. So after selecting this, I'm now going to work with the getting the algebraic equation. So it's going to plus, go row wise. C remains C, with D negated itself, which means C only remains. I'm going to go from here. This is the start, this is the end. Go from here to here. A bar becomes A, which means A cancels out. But B bar still remains B bar. So all we're going to left is B bar. And you can see from here that we have selected all the ones, so we are done. And this is our final equation. You can just name it X if you want. This for the HW lights. Now you can make some factorizations. I know I can see A bar here, I can see A bar here, I can also see A bar here. So I can just say A bar B bar plus D plus C. Next, I can see B bar is common to this, so B bar D plus C plus CD. Now you can draw the logic gate for this. You're going to have output A, B, C, D. I can see that. So you can see here B plus D plus C, but B is negated, so I'm going to draw a NOT gate for B. NOT gate is demarcated, it's a triangle with a dot on top plus C plus D. I'm going to join all of them in an OR gate. Let's make this line long. In an OR gate because they're all adding up. This output is B bar plus D plus C. Now A bar, that's negation, is multiplying it. So I'm going to bring it down here and multiply them in an AND gate. It's not in AND gate, sorry. So this is just it. Now next, let me move on to this next equation. I can see that B bar, that is what's here, is multiplying, sorry, rather let's start what's in the bracket. I can see D and C are adding up. So I'll bring them out in an OR gate. This is the output is D plus C. And B bar is multiplying them. So this is B bar because it's coming after the inverter gate. I'm going to multiply it in an AND gate with D plus C. So this output is going to be B bar, D plus C. Next, I can see C and D are multiplying each other in an AND gate. I'm going to bring it, both of them, in an AND gate here. And so now, where all of them are adding up in an AND gate. So I'm interested here. I'm going to add all of them in an. So I'm going to put all of them in an AND gate. So in an OR gate rather, not AND, because they're adding. The output is going to be, let's just say it's W. It's W lights. So that's how you get for SW. Let's just make this AW to be much more accurate. So, and let's get back to the question. That's the final output. Let's get back to the question. I say I'll come back to the north south lights. So next we're going to work on the north south lights. That is here and here. So the north south lights, the conditions for it. The north south light to be green whenever both lanes A and B are occupied. That means A must be 1 and B must be 1. But C and D are not both occupied. So C and D can be 1 and 0, 0 and 1, 0 not occupied at all, or but they can never be both occupied. This is wrong. So this is the conditions we're going to be working with for the north south light. The second condition is it will also be, we'll get back to the second condition. So let's fulfill the first condition on our truth table. So here, let's look for where A, to simplify everything. Let's look for where A and B are 1 and 1 because that is part of our condition. You can see that is just over here. So the first line, A and B are both occupied, but here C and D are not both occupied. So here we have a 1. Here, A and B checks out, and the C and D are not both occupied. Here it checks out, C and D are not both occupied. But here A and B are both occupied, but C and D are both occupied. That is going to give us a 0 as our output because we cannot have that. You can see it. We cannot have that. So now the second condition for working with the north south lights. So looking at our next condition, I'm going to erase this, which is here. So north south lights will be green when either A or B is occupied. So A can be 1, B 0, or A1, B 0 is occupied, while C and D are both vacant. So C and D must be 0 and 0. So let's look for where we can see A as 1, B as 0, or A as 0, B as 1, and where we can see C and D as 0, 0. To narrow down the search, we're going to just look for places where we can find this condition. I see that the only place where we can find these conditions is here. And we also, yes, so let's start with this line. A and B are only one is occupied. This checks out. And C and D are both not occupied. This checks out. A or B is occupied, but C and D are not both occupied. This can give us 0. This line also give us 0 because C and D are both vacant. Rather, are not both vacant. Here they are not both vacant. Here they are both vacant. Here they are not both vacant. C and D. I'm looking at C and D now. C and D are not both vacant here. C and D are not both vacant here. So this is what we'll have as our final answer. Now to assign the products of sums, A bar because A 0, B, C, D. C and D are 0. Next we're going to have A, B bar because B 0, C 0, D is also 0. Next here, we're going to have A, B, C bar, D bar, because they're 0. We're going to have A, B, C bar, D. We're going to have A, B, C, D bar. And here we're not going to have anything because that's 0. So now we're just going to draw out our K map. I'm just going to move this out of the way. So now let's work out on our K mapping. We're going to have AB, A bar B, AB, and AB bar. Next we're going to have CD, 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 and CD bar. Next we're just going to put in our values here. So we see A bar B, that is here, and C bar D bar, that's here. We're going to put our 1 here. Next we see this column AB bar, which is here, and C bar D bar, that is still this column. We're going to put our 1 there. We're done with this. Next we see AB, that is here, C bar D bar, that's still this column. Going to have 1 here. Next we still have AB, that's this column, and C bar D, which is here, C bar D. Let's have 1 here. Next we have AB, that is this column, C D bar, that's here. So we're going to put that 1 over here. Now it's time to select in groups of 4. So you cannot select group of 4 here, but we can select a group of 2 here. So I'm going to write this. When I go across row, I see that, let me erase these arrows. When I go across row in this direction, I can see that C bar, C means C bar, but D bar negated itself. So we're going to have just C bar saved here. And when I go here, I'm just saying only AB. So it's going to be A, B, C bar. Plus, let's select our next set of 2. Let's select this. So this is going to be when we go across the row, that's from here to here. You see that when we go from here to here, you can see it was A bar DM became A. It's going to cancel out itself, but B still remains the same. So we're going to have B. And when going across here, we're just going to have what's on that column, C bar D bar. Next, we're going to select this group of 2. So we're going to select this group of 2. And we go across, we're going to see that A still remains A. However, B negated itself, so we're just going to have A left. And when we go across the row of it, it's just left with C bar, D bar. And then this last one, you can see it's isolated. So I want you to watch closely on how I'm going to do the selection. I'm going to select here, it's at the edge. I'm going to select exactly what's opposite it on the other edge. See what I'm selecting. So you can do this in Karnaugh mapping as long as they're on the edges. So this is going to be when I'm going across the row, it starts from here. So I'm going to start my counting from here and it ends at this point. So I'm going to stop my counting here. When I'm going from here to here, you can see that it was C bar, then it became C. It's going to cancel itself, but I can see D remain D bar. So D bar is going to be here. And when I'm on this row, I can see that it's AB left. So AB. This is equals to north south. These are north south. I'll put for our north south lights. So you can just make a little bit of factorization. Left to it. I'm pairing up these 2. And I can pair up these 2. Factorization helps your logic gate to look a bit more easier. So B, C, D. Because I'm going to deal with this first. I can see that so this is C bar, negation, C D bar, and they're adding up in an OR gate because they're adding. Now next, I can see that A and B are multiplying each other here. So, and they multiply with this output here, which is C bar plus D bar. This is A, B. They are multiplying, so I'm going to join them together in an AND gate. So this output is A, B, C bar plus D bar. Next, we're going to have C. We're going to do what's in bracket first. We have seen B plus A, so I'm going to bring out B. Sorry, you must always flip around so the name is not connected. This is A. I'm going to also bring out B. I'm going to add them together. And next, they are being multiplied by C bar D bar. That is this. This is C bar and this is D. They are both multiplying each other and they are multiplying with what's here. So this is C bar D bar and this output is B plus A. And we're going to AND them together. So this output is C bar D bar B plus A. And next, they are all adding each other. So I'm going to join them all in an OR gate. The output is our north south. So we have successfully designed our logic circuits using the conditions that were given. Thank you for listening and I hope you understood the, the tutorial. Thank you. Please do not hesitate to leave your questions in the comment section if you do not understand anything. Thank you.